In this video on systems of equations, we're going to be looking at our first non-solution system. Now, this is different to an infinitely many solutions problem and a unique solution problem. When we have no solution, it means that the planes don't all meet at the same place, whether that be on a line or at a single point. Now, this one's a little bit more obvious because we have three parallel planes. Remember, a solution is where planes meet, so if they're parallel, they're never going to meet at all. So we can see that we have no solution in this case. Let's look at our contextual example to see how this comes about. Once again, pets with food packs here, but with a slight change in numbers. So we're going to put this information into our system solver to see if we can figure out a cost per gram for protein, carbs, and fats. Okay, so we'll put this in the solver now. And notice that it comes up with the same error text from our previous video on infinitely many solutions. Now, once again, it doesn't tell us whether it's infinitely many or no solutions, so that's why we need to delve a little bit deeper into what the equations actually look like and what it looks like geometrically. So in this case, a solution might be given to you, but it's always worth checking to see whether that solution actually works. So when I did this myself, the solution that it came up with was wrong because this is a no solution problem, and that's just an error from the program. Let's have a look at this geometrically. As we can see here, when we graph our three equations as planes in three-dimensional space, they are parallel, so they don't touch and they're just shifted a little bit apart. So because they don't touch, of course, they're not going to have a solution. So three parallel planes don't intersect at all, so there are no solutions. This is the first type of solution system that is called inconsistent. So inconsistent just means that a solution for one equation or a point on one plane does not match for the other equations or planes as well. And we'll see why that comes about in just a moment. Let's have a quick review of those equations. So here they are here. We can see that if we look at it in a bit more detail, this is food pack A, B, and C. Food pack A is made up of 1 gram of protein, 1 of carbs, and 1 of fats, and it costs $1. Whereas food pack B has exactly the same combination, but it costs $2. So remember that we're trying to figure out the cost per gram of protein, carbs, and fats. But if the food packs cost a different amount with the same number of ingredients, then of course the cost is going to be inconsistent amongst the different ingredients. And that's why we call it that. It also means that we can't solve the problem because the cost changes between different pieces of information. So how do we spot this a little bit more clearly? Well, what you want to look for is the equations being almost exactly the same. And I know they don't look like that at the moment, but what I can do is actually multiply everything in each equation by 3. So that's actually going to change to 3 now. And I'll do the same thing with food pack B. So that's going to become this here, and that will become 6. And notice that the equations are almost exactly the same. The coefficients are the same in all 3. However, the constant term at the end is different. So that's what you want to look for. All 3 equations have the same coefficients, but different constants. And yes, you might need to multiply to do this. So that's why it takes a little bit of working out. So why does this happen? Well, the coefficients determine the direction or the angle of that plane. So that means if they're all the same, then they're all going in the same direction or have the same angle, which means they're parallel and will never touch. The constant term determines its position. So if those are different, then it has been shifted a little bit, but they're parallel. Now that of course means that they're parallel planes and can't meet, and therefore we have no solutions. And that's it. Thanks for watching.